Hello, everyone. I would like to introduce Autokube, a tool designed to simplify microservice management in Kubernetes. This project is part of our ongoing research into achieving the vision of autonomic computing, ACV, by leveraging the capabilities of large language models, LLMs. For more details, feel free to visit aks.ms/acv-l. The motivation behind Autokube stems from the significant mental and physical stress often faced by cloud service maintainers when managing microservices in Kubernetes. The challenges include navigating a vast number of concepts and tools, memorizing complex management commands, and tracking numerous service components and metrics during issue resolution. These pain points become even more severe as cloud systems grow in complexity, scale, and distribution. With the advancements in large language models, LLMs, we now have an opportunity to simplify microservice management in Kubernetes. Autokube achieves this by introducing an LLM-based intelligent management layer on top of Kubernetes' existing management framework. The basic features of Autokube include enabling users to specify operational tasks in natural language, simplifying the setup of a multi-agent management system tailored to your service, and ensuring ease of operation within the agent-based management system. On a more advanced level, Autokube supports self-management of microservices when their SLOs, service-level objectives, are defined. Looking ahead, the system has the potential to enable agents to continuously learn from past failures or through self-exploration, paving the way for truly autonomous microservice management. Next, we will demonstrate the usage of Autokube with the popular microservice demo project, SockShop. SockShop simulates an online shopping platform with service components such as front-end, catalog, payment, and more. Autokube can be seamlessly integrated into SockShop by deploying several low-level autonomic management agents, each dedicated to managing a specific service component. Additionally, a high-level autonomic agent oversees and orchestrates these low-level agents, ensuring effective coordination and streamlined operations when required. By choosing the AutoGen framework and RabbitMQ for message transmission, we have built a comprehensive multi-agent architecture. Here are the demo for several cases in different scenarios. Let us start with the setup of Autokube on SockShop. Previous to Autokube, the current practice was to directly interact with the system using commands like kuberctl. With Autokube, everything becomes effortless. The assistant automatically retrieves the component list within the cluster and seamlessly sets up a configuration file for your agents. One agent is assigned to each service component, along with one high-level agent for the entire service. These agents are linked in a hierarchical structure, as introduced earlier. After deployment, you can interact with the cluster using natural language, making it significantly easier compared to the previous command-based approach. You can easily call the agent to execute query commands about the configuration file. When executing tasks, the manager agent will assign the appropriate component agent to complete them. You can review the agent's chat logs, which are saved locally in a Markdown file. Also, you can view the logs through a user-friendly web UI. In the web UI, you'll have access to the prompts and responses generated by our agent system for a clearer and more interactive experience. At the end of the chat round, the answer to your query is displayed in the terminal. For example, it provides the image of the catalog component. Now, let's dive into some operational tasks. As shown in the portal, both the catalog component and the front-end component currently have only one replica each. I'll call the agent to scale them up by adding more replicas. Excellent. It works seamlessly. At the end of the process, the agent will report the modification results to you. We have also set up security warnings. When the model performs an action that could impact the system, a warning will be sent to the user, who can then decide whether to proceed with the operation. You can choose to enable this option. The agents can also analyze the root cause of issues affecting pods in your cluster. For example, we can inject a pod failure chaos into the catalog component, as demonstrated in the portal. As observed, the catalog pod has entered a crash loop backoff state. Let's run the assistant to analyze the root cause of this issue. By combining insights from the manager agent and component agents, the assistant identifies and reports the root cause of the pod failure. In this case, it correctly determines the issue. We intentionally used chaos mesh to inject a fake image into the component's configuration file. You can also define your service level objectives, SLOs, to guide the agent in determining whether the components in your cluster are in a healthy state. In this case, we provide 2 query functions and integrate Prometheus to monitor the latency of the pods. As displayed in the terminal, the latency results have been successfully detected. Furthermore, you can easily switch to another cluster by traditional ways, as long as you call the setup function. You can also let Autokube monitor your cluster deployed on cloud platforms, such as Azure Kubernetes Service and others. With Autokube, you can simplify your microservice management in Kubernetes. Our demo can be accessed from our project website. Be free to have a try on your own cluster.